Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Mustafa Bisul Hakim, a second semester Master of Science student with student ID 2022494002. My supervisor is Dr. Wan Fazlidah Hani Abdullah, while my co-supervisor is Dr. Ili Shairah Abdul Halim. Today, I will be presenting my progress report entitled Parallel Sensing of pH, Nitrate and Electrical Conductivity in an IoT Framework. Sensors are devices that produces voltage value in response to what it measured. This research focuses on potentiometric sensor, which is one category of the electrochemical sensor for ion detection. The potentiometric sensor used is ECFET and extended gate field effect transistor. Fig 1 shows an ECFET, how an ECFET works. The gate of a MOSFET is detached and exposed to the target solution. We call this the sensing electrode or sensing layer. Adding another electrode as reference, an electromotive force will be induced, which indicates that there is an ion activity, and that ion activity can be selectively evaluated and measured. Nowadays, people talk about the Internet of Things (IoT), and everyone wants to implement IoT in the system. It is not a surprise if I say that ECFET also can be used in IoT as other sensors. However, this is not without problem. Before going deeper into IoT-related problems related to the sensing module in general are identified. The term sensing module is a combination of a sensing layer and the interfacing circuit. Firstly, the sensing module of ECFET devices are usually separated by its specific function. Most researchers did experiment on detecting one ion at one time instead of multiple ions simultaneously. Moreover, we also find out that an electrical crosstalk may also exist between the sensing layers that give out false positive value. Crosstalk noise also creates errors and faults in circuits. Both factors will hinder the process of parallel measurement. The next problem is related to IoT. There is an uncertainty of the best data sampling rate for data averaging, thus some of the data may be lost. The graph may look like this in gray, where sampling rate is high, and it also may look like this, the yellow, when it is low. In continuation of the problem, for simultaneous and continuous measurement, sensor data collected will be enormous and will be hard to manage and analyze. This brings us to the objective of the research, which is the main objective is to investigate the best environment setup for parallel measurement using integrated and multimodal sensing module in an IoT framework with ECFET by reducing crosstalk and minimizing data loss. The first objective is to design an integrated sensing module using ECFET and circuit transducer for multiple sensor measurement of pH, nitrate and EC values with reduction of interference caused by parallel measurement and undesired crosstalk. The second objective is to integrate multiple analyte sensor module in IoT framework with investigation on data averaging implementation towards maintaining data integrity of sensing module performance. To summarize, the first objective is to integrate the sensing module while reducing noise, while the second objective is to integrate the sensor with IoT and maintain the data integrity. So table 1 and table 2 shows the reference used for the lecture review. To summarize table 1, electrical crosstalk produced may be due to the same ion measured, interfacing circuitry, and PCB tracing. Some of the reference include the circuit model for crosstalk while others don't. Lastly, isolation technique and filters can be used to handle crosstalk in circuit design. The closest FET devices that minimize crosstalk in the reference is ECFET, while this research focuses on ECFET. So this can be considered the research gap for this research proposal. Meanwhile, table 2 shows the literature review that focuses on software for IoT integration. The scope of the research is microcontroller, connectivity, database, and the user interface, as these parameters complete the IoT framework. Figure 2 shows the overall proposed research framework. To cater the two objectives from before, the framework are divided into two. As encapsulated by the blue box, we have the sensing circuit where we will test the sensing layer of RIC for single point sampling to prove sensitivity and integrate all sensor module into one. Next, we will prove crosstalk and create isolation technique in circuit design such as power isolation and multiplexing. Moving on to the methodology for the IT framework in the orange box, we will first do the connectivity setup from the sensing module to the server via Wi-Fi and LoRaWAN. At the same time, we will also set up cloud server with a few software such as a Pro-based development tool, database, and the dashboard. After testing the connection of both setup, we will do demonstration of XFAT data unity framework. Figure 3 shows the scope of work covered in this research. The research will cover circuit design, connectivity setup, and cloud server setup as explained in Figure 1. Things that are not covered in this research is the fabrication of sensing layer and the development of Android software or application. The sensing layer used will be fabricated by the research group. To give a clear view for the panels or to everyone else, this figure shows the process of obtaining data for source sample analysis. When sensing layer are deep in the solution, a readout interfacing circuit RIC will translate the response into voltage and pass the value to the microcontroller. The microcontroller will then send the data to the database in the cloud, and user will then visualize the data in the dashboard installed in the cloud. The numbering above the certain boxes indicates that the scope of work explained in the previous slide. The term from indicate hasil MLA and not daripada. We also have analog circuit modification from the schematics and PCB design, microcontroller from firmware design, and cloud setup from IoT configuration. The skill and tool that are required is Forte software for circuit simulation, Eagle for PCB design, Forte1 for PCB tracing and component soldering. Next is ESP32 and TTGO microcontroller, Arduino IDE platform to code and IDEC. Lastly, for cloud setup is CTN or the things that work for LoRaWAN, DigitalOcean for the cloud service provider, PuTTY to install software inside DigitalOcean, and Node-RED to sort data packets in FlashDB as the database and Grafana as the dashboard. For the Gantt chart, we have completed part 1, part 2 in the last semester, which covers the research proposal, DRP, connectivity setup for Wi-Fi and LoRaWAN. For this semester, we also have covered data averaging in part 3 and cloud server configuration in part 4. Currently, we are doing part 5, which are the circuit design until the end of the semester. For the next semester, we plan on collecting data for testing and finishing up the thesis. Next is the status of publication. For this semester, we have submitted a total of 3 publications, which 2 of them are journal and 1 is conference paper. The first journal from IEEE census letters are rejected, while the second journal are still awaiting response. The conference paper are accepted, and we will present the findings at the end of August. Next is the status of thesis writing. There are a lot more to write and improve, and as of now, the writing are only done on average of 35% complete. The writing process will be fast forward after we perform the data collection for the next semester. Lastly is our planning for the next semester. We will perform soil testing and finish up the writing process. We will also submit at least 1 journal in case this semester we wasn't able to do so. This is the reference used in this slide. That's all from me. Thank you so much for listening.